what is TCP and UDP? These are the most common protocols used when doing networking. So we have TCP, which is Transport Layer Protocol, and we have UDP, which is User Datagram Protocols. And this is a way of transferring information between computers and over networks. And we have a graphical illustration of how they work right here. So with TCP, we are, when sending messages, getting an acknowledgement of that message. Whereas in UDP, we are just communicating one way, we are just transferring a lot of data in one direction. So let's take a closer look at each of these. So in the TCP, this is a connection-oriented protocol, and it is a one-to-one oriented protocol as well, meaning that we cannot use it for broadcasting messages because we need to establish a connection between a client and a server in order for us to communicate. So TCP is initiating what is called a three-way handshake, and that is illustrated in the picture right here. So for example, if we have a client that wants to talk to a server, the first thing that the client is going to do is send a message to the server. Then this server is acknowledging that message, saying that I received your message, do you receive mine? Then the client say as the last part of this three-way, yes, I received it, and now the connection is established. The reason why we have this three-way handshake is because, let's take an example where we communicated to the server and our message got through. So we send hello server, and our server say, oh yeah, I got your message, do you got mine? And then even though we got to the server, there might be a firewall rule blocking this message from getting back to us, meaning that we don't get an acknowledgement. So in order to confirm that the server can talk to us and we can talk to the server, we need this three-way handshake before our connection is established. So how is the packages that is going to be transferred over TCP, how do they look like? So when we are communicating data over a network, we are breaking our communication down to packages, because we just can't say here is 10 gigabyte of data and then just throw it at a server. That doesn't work like that. We need to divide them into smaller packages that we can then send. And if you haven't seen the first 5 videos of this course, then I recommend you to do so in order to understand some of these concepts. But when we are communicating data over a network, we have a stream of data, which we can see right here. So take for example this message we have here, Winslow Academy. If you like our videos, remember to subscribe. This is, let's say this is a long message. I know that it is quite short, but just imagine that this is a very big message. So what we're going to do when communicating this, for example, to our friend over a network, we're going to break this down into smaller packages. And since this is TCP, we need to have a header on our packages. We also have that with UDP, but with TCP we need a 20 byte header. And that is because when we are breaking down these messages, as you see right here, we are just breaking them down on random places. So for example, this is one package, this is another package, and so on, meaning that we have 80 bytes of body left to our data. So before our friend could understand what we are sending him, we need to identify the packages. So in the header we are going to put port number, the size of the package, the signature, and the number in the row, in the line of packages that we have. So this is for example package 2 in this line of packages, because in TCP we need to confirm that we have received the package. So the first thing that we are going to do is to send this first block. We'd only have Winslow. Then our friend will say, oh yeah, I got this package, send me the next one. And then we're going to send him if a cat, and then send him that, and so on. But imagine if one of these packages got lost, then this message will be, you couldn't read it, because then he would just get a message of and he would like, what does that mean? So that is why we need to say that we need these acknowledgement of packages, and we need the numbered order, because then he can say, okay, I got package 1, and then suddenly, wait, now I got package 3, I must be missing package 2. So he say, can you send me package 2 again? And we will send him package 2 again. And then once all packages is sent, then our friend will break these down and reassemble them such that he can read the message. So this is basically how TCP works, and since we are numbering these packages, we can break our data up any places. We don't need to say that it has to be an entire word, because he will know what order to read them, and if he is missing one, he will just ask for it. So UDP, this is a different protocol compared to what we have just discussed. So UDP is the user datagram protocol, and we do not have to verify that we have a connection, and there is no three-way handshake in this protocol. And we are not limited to one-to-one communication, meaning that we can use it to broadcast messages. And as you see on this picture right here, our computer or client is asking, are you getting the messages? And our friend is just saying, I don't care, just send it, meaning that just give me the data and just push it. I don't care if I miss a package or something get corrupt or what order I get them, just throw them at me because I need them fast. So how does that work when we look at packages? And as we saw before, we divided our packages into equal sized packages, meaning that these are all equal size, because we can use the max length of a package, because we don't need to care about the meaning of the words. But in UDP we actually does, because if you're missing a package, then we can't let him have a half word. We need the entire. We need to break the message and data up in where it make logical sense. So for example, here we are having the first packages with just the word hey, and then the next one is it's not too late to subscribe, meaning that he could still make sense of this word and this sentence even if one of them is lost. So that is basically the main difference between TCP and UDP, and since we are not getting all this information about the number of the packages and so on, we can have a much smaller header, but we cannot utilize a max length of the data packages, because we need to make these logical splits, and that this makes our packages in different sizes. So where are the TCP and UDP used? For example, when you're transferring a file over a network, you're using TCP because you need to be sure that the entire file is getting transferred. But UDP, on the other hand, is for example used when you're streaming online. When you have these streaming services, which for example YouTube that you're watching now provide 4K views, then it doesn't matter if one package gets lost or something, because the quality will just have a quick drop and then go up again, because you can't be waiting for your server and client to communicate and say, hey, do you got this package? Yeah, send me the next one. Okay, do you got this one? Yeah, I got this one. When streaming, you just need the data as fast as possible to keep up the quality and to be able to view it without lagging and having the browser just spinning and waiting.